Hello everyone, this is Srinivas from ASR Express, and today I will be solving an physics MCQ paper for you. This is the paper from the May June 2024 series, paper 2, variant 2. So let's get started. Question number 1. A student wishes to measure accurately the volume of approximately 40 centimeter cube of water. She has two measuring cylinders, a larger one that can hold 100 centimeter cube and a smaller one that can hold 50 centimeter cube. The water forms a meniscus when it touches the glass. Which cylinder and which water level does the student use to ensure an accurate result? Okay, so for this, imagine the scale on the measuring cylinder, something like this. So you can see that the water takes a smaller portion of the scale firstly. So it's a smaller portion of the scale compared to the smaller one. Secondly, the scale on the larger measuring cylinder, it has greater spacing between it. So when it has a greater spacing in between, each smaller subdivision of the scale corresponds to a smaller centimeter cube value. So that means that there is a greater uncertainty in the answer. So the distance between these two subdivisions will be much more greater. So when it is greater, we won't know if it's, for example, 40.65 or 40.64 or 40.63. So that's quite a lot of uncertainty, and that can create some inaccuracy in the result. However, when you're taking this as your value, you can see that it is occupying a greater scale. Like it is part of the much bigger part of the scale, so and the subdivisions are much smaller here. So when it's much smaller, you know that if it's 40.6 or 40.7 or 40.8, and that's much more that's more accurate as a whole. Secondly, let me just erase all this. Secondly, you always have to read from the bottom of a meniscus for a low viscosity fluid. When a fluid has a higher viscosity, it has a meniscus something like this. When it has a meniscus something like that, you have to read from the top of the meniscus. However, water is a low viscosity fluid, so it has a lower meniscus. We read from the bottom of the meniscus because that's where most of the water is. When you take the bottom of the meniscus, the top of the meniscus is only a very small portion of the water, of the total volume. So when it's a smaller portion of the volume, it means that it can be neglected because it's a very small value. So we always measure from the bottom of the meniscus. So the answer is C. The smaller one's used and the bottom of the meniscus is read. Okay. The motion of an object is represented by the speed time graph shown. Which quantity is equal to the area under the graph? Okay. So the area under the graph would be the height and the time. Right? So the height is just V and the time is T. So what is V into T? It is the distance. So the area under a speed time graph is always distance, because we're multiplying the values of speed and time together. When speed and time are multiplied together, we get distance. So it is distance traveled. So it's 2C. Third question. An astronaut of mass 80 kilograms is standing on a planet with gravitational field strength G is equal to 3.8 Newton per kilogram. What is the weight of the astronaut on the planet? Okay, so the astronaut would weigh W is equal to M into G. We know the mass to be 80 kilograms, and the force on the mass, the actual gravitational constant, is 3.8. So it's 80 into 3.8. That is 304 newtons. C naught force very close to 300 when rounded off to two significant figures, so its answer is B. 4. A sealed container of volume 2000 centimeter cube contains air at high pressure. The container is placed on a top pan balance. The balance reads 200 grams. All the air is removed by a vacuum pump and the balance reading changes to 196 grams. What was the density of the pressurized air? So, to find the mass of the air inside, we just m air is equal to the difference between the filled container and the difference between the empty container, because the air has been removed, it's a vacuum inside. So that's just 200 minus 196, which is just 4 grams, and rho or density, rho is the symbol that we use to show density, is just mass by volume, which is, so it's 4 divided by 2000, just so that's 2 into 10 to the power minus 3, so that's 4a. And remember that the unit is gram per centimeter cube, since the weight is in grams and the volume is in 2000 in centimeter cube. Okay, the fifth question. Each diagram shows three forces on a beam. In which situation is it possible for the three forces shown to be in equilibrium? Okay, when an object is in equilibrium is when there is no net moment and no net resultant force. Okay, so let's calculate the resultant force first, because that's the one that's easier to calculate. So here the resultant force is approximately same, so this ticks the resultant force. For the second one, the resultant force is not the same, because there are two values traveling upwards and there's only one coming downwards. So this would have a total net resultant force upwards, because the forces are not balanced. So this does not tick the list. Secondly, again, this has two forces upwards and one force downwards. That means it has a total net force of upwards, which is not in equilibrium, so that is not right. Now, this has two smaller forces acting. This has two smaller forces acting and one bigger force, which is approximately the sum of the two forces. So this is in equilibrium, similar to A. So that is also in equilibrium. However, so we know C and B are not answers. So between A and D, let's just check for the no net moment. So here, this is acting in the center and these two are acting on the edge. So if we consider this to be the pivot, this has a lower net moment, this has a higher net moment, because technically when we take this as an entire force, the total distance is greater from the pivot. The total perpendicular distance from the pivot is greater, and when the perpendicular distance from the pivot is greater, because moment equals F into D, so force times distance, the force is the same, the distance is greater, so this does not have a net moment. So this does not have, sorry, this has a net moment that moves in the clockwise direction. So the answer is 5D. 6. A gymnast jumps down from a high piece of apparatus. She gradually bends her knees as she lands. Which effect does this have? Okay. She will have a smaller change of momentum as she lands. She will lose less kinetic energy as she lands. She will exert a smaller impulse on the ground as she lands. She will experience a smaller force from the ground as she lands. Okay, so let's just try to eliminate the wrong answers first. She will have a smaller change of momentum as she lands. That is not true, because the total change in momentum is just going to be mv minus mu. M is constant, so v minus u. Now we know V is going to be same, U is going to be the same no matter if she bends her knees or if she doesn't bend her knees, because V is the final momentum and U is the V is the final velocity and U is the initial velocity. That's going to remain the same. The final is going to be 0, the initial is going to be U. If the initial is going to be whatever speed she jumps at, so it's going to be always the same. V minus U is going to be the same. Okay. However, she will lose less kinetic energy as she lands. That is also not true, because again, like I said, V squared half into half mv squared minus U squared. That's the change in kinetic energy. So delta Ke, because half mv squared minus half mu square, we just take the half m outside, so half mv square minus U square. That means that the kinetic energy she loses also is going to be the same, because the velocities, like I said before, are the same no matter if she bends her knees or not. She will exert a smaller impulse on the ground as she lands. Impulse is just going to be Ft equals mv minus mu. It's the same as change of momentum. So if change of momentum is going to be the same, the impulse is also going to be the same. However, she will experience a smaller force on the ground as she lands. That is true, because the total contact time t is going to be greater than when she doesn't bend her knees, because she is bending her knees, she is traveling downwards for a greater time. So that means her legs are on the ground, so the legs, they are on the ground for a longer time. So t is greater now. When t is greater, F is equal to mv minus mu by t, the rate of change of momentum. When t is greater, when the denominator is greater, the value decreases, so F decreases. So she will experience a smaller force from the ground as she lands. 6D. Okay. The table gives 4 energy resources and states whether the main source of energy for the resource is the sun. Which row is correct? Okay, geothermal. Main source of energy is the sun. That is not true, because geothermal energy is produced by the energy of the pressure and heat created by the magma and the temperature of the core and the magma of the earth. Okay, so the energy resource for oil, the main source of energy is the sun. No, that is not true, because oil is produced by the fossils and the fossils of like prehistoric animals. So those animals would have derived their energy from the sun, because they would have been herbivores, or they would have had herbivores for food. So when they preyed on herbivores, the energy is traveling through the food chain and it is ending up in the animal. So the main source of energy is the sun. So that's also not true. So this is not true. This is not true. Water held behind a dam, main source of energy is the sun. That is not true. 7C. Okay, sorry. The water held behind this dam, the main source of energy is the sun, because your water gets held behind a dam because of the water cycle, and water cycle is caused by the actual energy from the sun. Water evaporates and forms rain, and that rains, and that causes water to be held behind a dam. So the main source of energy is the sun. So this is right. We know that for wind, the main source of energy is the sun. The sun heats the land heats the air. This causes high density and low density regions to form, and this causes convectional currents to form in the air. So when convectional currents form, that's when wind forms. So the answer is 7C. All this is wrong, this is right. 8. The equation delta P equals rho G delta H can be used for liquid. What is the meaning of the term rho? Rho, this symbol, this is known as rho, and rho is always the density of the liquid. So for example, if it's water, we use the density of the liquid, so the density of the water. So it's 8B. 9. What are the correct terms for each change of stage? Liquid to solid is solidification and liquid to gas is evaporation. So it's 9C. 10. Extremely small pollen grains in water are viewed through a microscope. The grains are seen to move continually and randomly. What is the reason for this random movement? A. The grains are moved by random moving water molecules. The grains are moved by random conventional currents. The grains are moved by random rays of light. The grains are moved by the random motion of their own atoms. And this is 10A. 10A, this phenomena is known as Brownian motion. So Brownian motion occurs when smaller water molecules are much smaller than the pollen grains, but they are much faster than the pollen grains. So because they have smaller mass, but they are much faster, they have a higher momentum. So when they collide with the grains start to move in random erratic movements. So this is known as Brownian motion, and it is caused by the random moving water molecules. So it's 10A. Okay. Which graph shows how the volume of a fixed mass of gas at constant temperature varies with its pressure? Okay. So when the temperature of a gas increases, its pressure also increases, but the volume of a fixed mass of gas so when the pressure increases, the volume is going to decrease along with it. So because when the pressure increases, volume decreases, because P is proportional to 1 by V or V inverse. So it is the answer is 11D, because this shows the inverse relationship. Okay. Which effect is caused by thermal expansion? A metal surface heating up in direct sunlight, melting on. Okay, it's 12C. A railway track buckling on a hot day. In railway tracks, the railway tracks expand due to the high temperature, and when they expand in the high temperature, they expand with each other, and this causes them to collide. So when they keep expanding, the railway tracks start to bend upwards, because they need to expand because of the high temperature, but there's no more space for them to expand. So this phenomena is known as buckling, and it is when the railway track tries to expand, but it hits each other, the adjacent tracks hit each other, and they move upwards due to the lack of space for them to expand. So it's 12C. Okay, 13. The temperature of the water at the bottom of a waterfall is greater than the temperature of the water at the top. The energy in the gravitational potential store of the water at the top is transferred to the thermal store at the bottom. Okay, the specific heat capacity of water is 4200 joule per kilogram degree Celsius. What is the temperature difference for a waterfall of height 21 meters? Okay, so we know that the GPE or EP, which is the potential energy caused by gravity, is the formula is mg delta h. So it's change in EP, and that's mg delta h. So the change in the height of the water, so that's moved from some height to down. And we know that Q is equal to mc delta T. We know Q is just the thermal energy of the water, and that's mc delta T. So m's mass, C is the specific heat capacity, and delta T is the temperature change. Okay, so when the water falls from the waterfall from some distance, the gravitational potential energy is transferred to the thermal energy. So E delta EP is equal to Q. So mg delta H is equal to mc delta T. We know m is constant, so cancels out. So it's G delta H divided by C is equal to delta T. And when we calculate that, that's just 9.8 into the height difference is 21 divided by the specific heat capacity, which is 4200, and that is 0.049 degrees Celsius, which is 13B. And we're right. Okay. An ice cube is placed in a beaker and is heated. The ice melts to form water, which evaporates at first and then boils. The steam condenses on a cold window in the room. Which process involves the transfer of energy from the ice, water, or steam to the surroundings? Okay, so it is no, it's not melting, because melting is the transfer of energy to the ice, not the vice versa. Evaporating is also energy transfer to the water. Boiling is also energy transfer to the water. However, when steam condenses, it transfers its high energy into the surroundings. So the answer is 14D, condensate. 15. A teacher shows his class a polystyrene cup. The polystyrene is a thick plastic with lots of tiny air bubbles in it. He asks the class why the cup is so good at keeping a hot drink warm. The three suggestions are made. It contains air, which is a poor thermal conductor. The air is trapped in tiny bubbles, so very little convection is possible. The plastic is a poor thermal conductor. And we know that air is a poor thermal conductor, so this is right. Air is trapped in tiny bubbles inside the polystyrene. It's a very foamy kind of material. It traps air, and that means that air cannot move. And when air cannot move, convection is not possible. So this is also right. And the plastic is also a very good insulator. So the plastic is a poor thermal conductor. So yes, so it's all of them are right. 15A. Two samples of the same material have the same mass but different surface areas. Each sample is heated to the same temperature and left to cool to room temperature. Each sample is allowed to cool to the same final temperature, which row correctly compares the decrease in internal energy and the initial rate of cooling for each sample. So we know that it's cooling to the same final temperature, and it starts from the same temperature. So when both of them start from the same temperature, we know that Q is equal to MC delta T. Delta T is constant here, so Q is going to be the same. So it's going to be X and Y loses the same quantity of energy, so it's going to be C or D. However, Y has a larger surface area. That means it has more contact with the air. So conduction into the surface of the air can be done, and then that can be convected around. So larger surface area means larger rate of cooling. So initial rate of cooling is faster. So the answer is 16D. Y cools down faster than X. So it's 16D. 17. In which type of wave is the direction of vibration parallel to the direction of travel? And that's B, because P waves, primary waves, are longitudinal, which means they travel something like this, where the direction of travel is parallel to the vibration. Longitudinal waves have that feature on them. So it's 17B, primary waves, seismic primary waves. 18. Waves in a ripple tank are diffracted as they pass through a narrow gap. What can be done to make the spreading due to diffraction greater? Okay, the spreading due to diffraction can be greater by making the wavelength of the by actually increasing the wavelength of the waves that are passing through. So to increase the wavelength, that's lambda. So V is equal to lambda into F. So V by F is equal to lambda. So when F decreases, when the denominator decreases, lambda should increase. So decreasing the frequency of the waves and keep the speed constant. That's going to be 18A. So that's the answer. Okay, 19. Diagram 1 shows the page of a book in front of a plane mirror. An eye is looking at the image of the page. Diagram 2 shows a large letter G on the page facing the mirror. What is the appearance of the image of G seen by eye? So it's going to be a mirror. It's going to be a mirror change, and that means it's going to be laterally inverted. So it's going to be 19D, because when we draw it like this, it's going to be something like this. So that's how that looks. Sorry, my drawing is not very accurate, but okay, something more like this. So that's the lateral inversion. Features on the right have moved to the left, and features on the left have moved to the right. So it's been flipped horizontally. So that's D. This is known as lateral inversion. Okay. The diagram shows a ray of light passing from air into diamond. What is the refractive index of the diamond? Okay, they have given us the values of the angles with the actual plane. So that means the angle of incidence is the difference between the values and the normal. So this is the difference actually. So that means we just need to subtract 60 from 90. So the angle of incidence is equal to 30. 90 minus 60 is 30. And angle of reflection is equal to 90 minus 78, which is 12 degrees. So sin I by sin R is equal to N. Sin I and by sin R is used here because it's rarer to denser. Diamond is optically denser medium. So sin 30 by sin 12 is equal to sin 30. This is 2.405 or 2.4. So the answer is 20C. Remember to always take the angle between the normal and the incident ray, not between the plane. This is a very common mistake by student, and please make sure you avoid that. Okay. The ray diagram shows the formation of an image by two different converging lenses. Which row describes the images produced? In diagram 1, you can see that it is behind the actual object, the image, and the lines are extrapolated and it cannot be formed on a real screen. That means this is virtual, and this is a real image because it is inverted. It is in front of the actual object, and that the actual screen, it can be visible on a screen. So the diagram 2 is real. So it is 21C. 22. White light enters a glass prism. The light leaving the other side of the prism is separated into colors. Which row correctly describes what happens? Okay. The path taken by the light is going to be different based on the color of the light, because the color of the light determines the refractive index of the light. And always one more thing that you need to remember is that it's going to be changed in the first refraction itself. So it's going to be diagram 2, because it's not going to travel until here in the same refraction, and then it's going to not change here, because the refractive index is different for both the colors. And since the refraction is happening here and then happening here, there's 2 times refraction. There's going to be two different separations. So this is going to separate slightly, this is going to be a greater separation. And secondly, red bends less than violet, because it has a lower refractive index. So that means color 1 is going to be red, color 2 is going to be violet, because red always bends less. So it's going to be red, then it's going to be orange, then yellow, and so on. Okay, thermal radiation is part of the electromagnetic spectrum. What is the name of this region of the spectrum? Thermal radiation is going to be infrared rays. That's the radiation that is associated with thermal radiation. So it's going to be 23B, infrared. A remote controlled vehicle is traveling on the surface of a planet. The vehicle senses an obstacle ahead. It sends a radio message to the control room from where it is being controlled. The control room is 2.4 into 10 to the power 6 kilometers away from the vehicle. The control room sends a message back to the vehicle telling it to stop. Okay, so the control room sends a message back to the vehicle telling it to stop. So first we need to measure the amount of time it takes for radio waves, which is just electromagnetic waves, so 3 into 10 to the power 8 meter per second, to travel there and come back. So it's gonna be the time taken. T is all, it's d by v, so it's 2.4 into 10 to the power 6 divided by 3 into 10 to the power 8, just so that's 8 into 10 to the power minus 3 seconds, or 8 milliseconds. So since it is traveling there, oh sorry, I made a mistake here. Since it is 10 to the power 6 kilometers away, you have to convert it into meters. So that means I'm really sorry, I made a mistake here. Sorry. So that means it is 10 to the power 6 into 10 to the power 3, because it is in kilometers. We need to convert it to meters. Kilometers to meter conversion is into 10 to the power 3. So into 10 to the power 3 into 3 to 10 to the power 8, which is just 8 seconds. Since the light has to go to the surface of the planet, then come back here where the control room sends a message like back, because it has to come back to Earth and then it has to again go back. So it's a total of 8 into 2, because it has to go back to the actual planet. So it has to like first arrive from the planet and then go back to the planet when the control room is sending a message to the vehicle. So it's 8 into 2, which is 16 seconds. The answer is D. 25. Which statement about the direction of a magnetic field at a point is correct? Okay. It is the direction of the force on a north pole attached placed at the point. It is the direction of force on a south pole placed at the point. It is the direction of force on a positive charge. It's direction of force on negative charge. When it's the direction of a force on a positive charge, it is the direction of an electric field. However, we're talking about a magnetic field here, so it's the north pole, so it's 25A. The direction of a magnetic field at a point is always the force on a north pole placed at the point. It is a definition written in the actual IGCSE 2023 syllabus, so please, it's always north pole. Okay, a student draws graphs of an AC supply and a DC supply. Which row shows the correct labels for W, X and Y? Okay, W is gonna be W is gonna be voltage, because that's what's actually changing. W is going to be voltage, since that's what we're measuring the y-axis. AC supply has a change in the y-axis constantly at regular intervals of time. It looks like a sine curve. So it has crest, it has troughs, it is changing at like regular intervals of time. So y is AC supply and X is DC supply. So it's going to be D, since the voltage is what's changing, not the time. So it's 26D. Okay, a resistor transfers 100 joules of energy when a charge of 10 C flows through it. What is the potential difference across the resistor? Okay, so E is equal to Q by I. Sorry, this E by Q. This is voltage. Sorry. V is going to be E by Q. So E is 100 joules. This is 10 C. So it's going to be 100 by 10, which is 1 Yeah, so 100 by 10 is just 10, so it's just 27b. Wire X and wire Y are made from the same metal. The table gives information about the two wires. What is the resistance of wire Y? Okay, so we know that something with a length of 1 meters is, and the cross sectional area of 0.4 is has a resistance of 2 ohm. So the resistance is always rho into L by A. So this is a trick that I have used in my board exams as well, and this is resistivity. Rho here represents resistivity, and that's a constant. So you can keep this as the base. So wire X is going to be, for R of X, is going to be rho into some length divided by the A. So you can just calculate resistivity here, or so 2 is equal to rho into 1 by 0.4. So 2 into 0.4 divided by 1 is going to be resistivity, so that's 0.8. Resistivity is 0.8. So then 0.8 into 1.3 divided by 0.3 is just 0.8 into 1.3 divided by 0.3. It's going to be 3.4 6 or just 3.5, so just 28d. You can also do this by just finding the since you know Rx is equal to, is proportional to L by A. You know that when we remove the proportionality sign, Rx is just going to be equal to some C into L by A. C is just the resistivity, but since that is not a prescribed equation in the IGCSE syllabus, you can also use this method and just find C and then calculate it. Okay. Now, the diagram shows two resistors used as a potential divider. The reading on the voltmeter is 1.8 volt. What is the resistance of the resistor R? Okay, so we know now that the total current passing through the series circuit is just going to be the current passing through one of this, because the current in a series circuit remains the same. It does not get split. Only the voltage gets split across components. So V is equal to I by R. So V is equal to I into R. So V by R is equal to I. So that's 3 by 5 into 10 to the power 3, since it's kilo ohms. So 3 divided by 5 into 10 to the power 3 is 6 into 10 to the power minus 4 ampere. Now I just need to find the resistance of this. I know the reading on the voltmeter is 1.8. So V is equal to IR. So 1.8 divided by 6 into 10 to the power minus 4 should give me the resistance. So 1.8 divided by 6 into 10 to the power minus 4, which is 3000 ohm, 3000 ohm or 3 kilo ohms. So 29. Oh, sorry, there is another mistake that I made here. This is not 3, since this EMF is being split across two resistors. So this has a resistance, this has a voltage of 1.8. This will have a voltage of 3 minus 1.8, which is equal to 1.2. So it's 1.2 divided by 5 into 10 to the power 3, which is 2.4 into 10 to the power minus 4 ampere, and 2.4 into 10 to the power minus 4 is the current. So it's 1.8 divided by 2.4 into 10 to the power minus 4, which is 7500 ohm. So 7500 ohm is nothing but 7.5 kilo ohm. So it is 29C is the answer. always remember that you have to calculate the voltage across one resistor, so you have to split it as per like what you want to do. And secondly, you also need to remember that the current across a series circuit is constant throughout the components. So when you find the current through one component, you know the current through the other components. Two electrical appliances are connected to this main supply. The cable connected to one appliance includes an earth wire. The cable connected to the second appliance does not need an earth wire. What is a reason for this difference? One appliance has a metal case, but the other appliance does not. One appliance is fitted with a fuse, but the other appliance is not. One appliance is fitted with a switch, but the other appliance is not. One appliance needs more current than the other appliance. Okay, so whenever something's connected to a main supply, it needs an earth wire, because the excess charges need to flow through a conductor into the ground, which has the zero potential. When it's fitted with the fuse, it still needs an earth wire, because the fuse only separates the main supply, but that does not mean that the earth wire should not be there, because current can still leak into the surroundings, or into the metal, or into the case where we can touch and accidentally get a shock. Only when we get the shock, the fuse is actually going to blow, so that can still lead to damage. When it is fitted with the switch, that still needs an earth wire, because an earth wire is there for protection and for a reduction of static electricity. And one appliance needs more current than the other appliance. Whenever something's connected to the main supply, it requires an earth wire, because that prevents accumulation of current. So it is one appliance is a metal case, because the metal case will in itself act as an earth wire. So when an appliance needs an earth wire, either it can have a metal case which can take the current successfully into the ground, which has a lower potential, or it can have an earth wire which is going to do the same task. So it's 30A. The diagram shows a simple AC generator. The magnet rotates around a fixed coil wound round a fixed iron core. The electromotive force output is a sine wave, a series of crests, zeros, and troughs. The magnet is shown in three positions, P, Q, and R. During its rotation, the magnetic field in the coil is 0 at Q, but changing most rapidly. Okay, so when the magnetic field is 0 at Q, it means that, but it's changing most rapidly, it means that the voltage here is going to be the greatest. It's going to be at the maximum. However, at position P, this means it just started spinning. The magnetic field in the coil is at 0. So this means there is the position P is one that is at 0. So position P has had a lower voltage. When it's coming to position Q, the magnetic field in the coil becomes 0, but it's changing very rapidly. That means it is in the intermediate stage, and that means the EMF is going to be at the maximum. This is something that you always need to keep in mind when you're solving questions like this. Just try to imagine the actual sine wave. So the sine wave is going to be something like this. This is going to be position P, where it is correctly changing into the new EMF, and this is going to be position Q, where it's going to be greater. So position Q is going to be greater than at position P. So that's something to keep in mind. Position Q is going to be greater than at position P, so it is 31A. 30B, the magnitude of the EMF at position Q is 0 is not true, because it's changing. A magnetic flux always creates an EMF, so that's not true. Magnitude of the EMF at position Q is smaller than at position R. No, position R is again going to be another 0 position. It's again going to be another 0, so it's not a 0. And the magnitude of the EMF at position R is larger than at position P. So no, this and this is going to be equal. So it's going to be same. So it's 31A. 32. A 24 volt power supply and a 100% efficient transformer are used to light a 6 volt 12 watt lamp. What is the current in the power supply? Okay. So we know that from 24 is being stepped down into 6 volt. So that's going to create that certain ratio, and it's going to be 12 watts. So P is equal to V into I. So 12 divided by 6 is going to be the current, so 2 amperes. So 24, so Vp by Vs is going to be Is by Vp, so Ip. This is the formula. So because the power is going to be remaining the same, so we can just use that. So it's going to be 24 by 6 is equal to 2 by Ip. So 2 by 24 by 6 is just 4. It's just going to be 2 by 4 is equal to Ip. 2 by 4 is just 1 by 2, so it's 32 A, 0.5 ampere. You can also just use 12 volt as the value, because P is constant through a transformer. So you can do 12 by 24, which is much simpler way of doing it, and that's going to give you 0.5 ampere. Same thing. The scattering of particles by a thin gold foil provided scientists with evidence for the nuclear atom. Which particles were scattered by the gold nuclei in the thin foil? And that is alpha nu particles, because the gold leaf Rutherford experiment was with the alpha particles. 33A. 34. A nucleus X has 17 protons and 18 neutrons. Which notation is correct for the nucleus? Okay. The proton number has to be, the atomic number has to be down, so it has to be something with 17 in the down, so C and D, either C or D. And the nucleon number has to be up, so it's 17 plus 18, which is 35. So 35x 17. So this is the nuclear notation. Okay, 35. The dashed line on the graph shows the decay curve recorded from a sample of a particular radioactive isotope. The count rate includes background radiation. Which curve shows the corrected count rate? So when this includes background radiation, the corrected curve will be exactly this with the same gradient but downwards. It's going to be shifted downwards. It's not C, because this is not shifted downwards per se. This is in the same y values, just shifted to the left. We want it to be B, because see here the gradient is also not constant, so it's going to be B because it's shifting downwards. The corrected rate is going to be the actual rate. No, sorry, the corrected rate is going to be the actual rate minus the background rate, so it's going to be lower than the actual rate, so it's going to be B. 36. Which type of radioactive source is suitable for use in measuring and controlling the thickness of paper in a paper manufacturing factory? It's not going to be alpha particles, because alpha particles cannot even move through air particles. It interacts very quickly, so that means none of the alpha particles will move through the paper. However, beta particles will move through the paper to some extent until the thickness is so when the beta particle radiation is too low, that means the thickness is too high. If it's too high, the thickness is too low, so that means it's going to be beta particles. However, we wanted to also have a long half-life, because we want a radioactive source for keep producing the beta particles. We don't want it to be very short to produce a large amount of beta particles immediately and then remove itself. We want it to be useful for a long period of time, so it's going to be long half-life, and the type of emission is going to be beta, so it's 36 C. 37. A medical tracer is used to investigate a tumor in a patient. The graph shows the corrected count rate. Okay, so the half-life is just going to be when the count rate becomes the half the value. So at what time it's becoming half the value? So at 10,000 to 5,000, it's taking 2 minutes, and from 5,000 to 2,500, it is taking 4 minutes, so it's another 2 minutes, so 37A, because that's the half-life. It's taking 2 minutes to decrease to the half. 38. The Earth orbits the Sun up once in approximately 365 days. The average radius of the orbit is 1.5 into 10 to the power 11. What's the average orbital speed of the Earth? So V is equal to 2 pi r by t. 2 pi r is the circumference, t is the time period. So circumference is just the distance across the orbit, so it's 2 pi r. So it's 2 into pi into 1.5 into 10 to the power 11 divided by 365 into 365 is the number of days, so we want the number of hours in each day, so that's 24. Now in hours we want the minutes, so that's 60 into another 60 for the number of seconds, so that's 38, and that's 38a. 3 into 10 to the power 4 meter per second. That's the answer you get. Okay, which statement about the life cycle of a star is correct? All stars eventually run out of hydrogen as fuel. A red giant forms a planetary nebula with a supernova at its center. A white dwarf star eventually forms a black hole. Most stars expand and form protostars. Okay. 39A is right. All stars eventually do run out of hydrogen as a fuel. So that is our answer. B, a red giant forms a planetary nebula with a supernova at its center. No, a supernova is the explosion of an explosion of a star creating a nebula, an interstellar nebula. A planetary nebula is when a red giant starts dying, it loses its outer coatings, and that creates a small planetary nebula because the outer coatings become larger and larger and eventually covers a long area, which is a planetary nebula. A white dwarf star does not form a black hole. A white dwarf star is when it's in the center of a planetary nebula, and it's when it's at the final stage of a star. A black hole forms when the supernova explodes. And most stars expand and form protostars. No, protostars are the stars that are formed immediately after the interstellar cloud of gas combines because of the gravity. So that is not also true. 39A. Okay, that's 39A. So my pencil is not writing, but okay, that's 39A. A galaxy at a distance of 3.1 into 10 to the power 21 kilometers is moving away from the Earth with a speed of 7,000 kilometers per second. What is the Hubble constant h naught calculated using this data, and what is the speed of a galaxy at distance of 6.2 into 10 to the power 21 from the Earth? So the Hubble constant is calculated using the distance and the recession speed. So that is just going to be 2.3 into 10 to the power minus 18. The h naught is calculated using the recession speed and the time, and it's also a constant that is compulsorily must to be known for the exam. So that's just 2.3 into 10 to the power minus 18. It's important that you remember that. And the Hubble constant enables us to find how fast a galaxy is moving away from us. So 6.2 into 10 to the power 21 into 2.3 into 10 to the power minus 18 would give you the speed of galaxy in kilometers per second, how fast it's moving away from us, because V is equal to h naught into the distance. So the speed of recession is h naught into d. That's the formula. You can also use this to find the h naught, but I would say just remember the constant of h naught, because it will help you for the other questions, because it's a constant that is quite easy to be remembered and it's pretty important for the exam. So I'd say you remember it. Yeah, and that is it for the physics May June 2024 paper. I hope this was helpful, and good luck for your exams. See you next time, and bye.